Welcome to the first of an 8-video series on polar graphing, general concepts. Before we begin, I have to warn you by saying that this video is not a how-to video. It will not show you how to do polar graphing in any form, but because that's what the remainder of the video series is dedicated to, we're opening up with just a general concept video on what is polar graphing. Nothing in this video is a step-by-step guide on how to do any particular math problem. And before I get to polar graphing, let's begin by just what graphing is in general. Suppose we had an equation with an x and a y in it, such as this one. These are the kinds of things that we would graph in middle school and early high school. And the way graphs worked was we would look for a value of x and y that would make the statement true. For example, we all know 2 plus 3 is 5. So we would determine that this statement is true when x is 2 and y is 3. We would often put that as an ordered pair or a Cartesian coordinate. And then what we would do with that 2, 3, or that xy pair, is we would create a graph, and we would say to ourselves, well, here's all the points for which x is 2, and here's all the points for which y is 3. Well, the only point they have in common is here, and therefore that red dot, that single dot, represents the true statement 2 plus 3 equals 5. And then what we would do is realize, well, this statement isn't true only when x is 2 and y is 3. That was just one example. So we would go out and look for other examples, such as x is 4 and y is 1, or x is negative 1 and y is 6. And we would continue to search for examples until we realized, hey, all these points, these so-called true points, points whose coordinates make the equation true, they're forming up to some kind of pattern. And once we realize what that pattern is, in this case a straight line, we draw that pattern and erase the particular points. Often teachers don't require you to erase those points, but honestly we should, because those points aren't special. They're just examples of numbers that add up to 5, and there are many other examples, and this line represents all of them. That's what graphing is. Now that probably didn't sound new to you, but it sets the stage for a better understanding of what polar graphing is. So then what does it mean to graph something in polar coordinates? Here's an example. Just a reminder, r and theta represent polar coordinates in which r is the distance from the origin and theta is the standard angle. If I were to take this expression and pick some random value for theta, say pi over 3 or 60 degrees, and do the trigonometry, this would work out to 3½ or 7/2. And what that shows me is that for my randomly chosen value of theta, r is 7/2. In other words, this is a true statement when r is 7/2 and theta is pi over 3. We could put that in an ordered pair, which we call our polar coordinates, or our r theta coordinates, and we could plot those on a polar graph. Now notice this represents all points whose angle is pi over 3. This represents all points whose distance from the origin, or r value, is 3.5 or 7/2. And here is the only point with both of those conditions met. And so that is the point 7/2 comma pi over 3. Well, this, you'll notice, was just one arbitrary choice of theta, which led to a specific value of r that corresponded to that theta. But Of course, those aren't the only pair of values r and theta that make this statement true. In fact, there's an infinite number of r and theta values that make this statement true. We can't find all of them, but we could find a lot of them. Now imagine that we were to continually do the process we just did. I won't show the algebra, but what if I picked a different theta and computed the r value and plotted that point? And then what if I picked another theta value, computed the r value, and plotted that point? And what if I were to continue this process with different values of theta, finding different values of r, until I had some general idea of where this graph was? What I could do at that point is simply connect up all the points, and then I would have a general shape of my polar coordinate graph. Now, just a reminder, this is not a how-to video, but what this problem shows you is that if you plot enough points in a polar coordinate system, you'll have a general idea where the graph is. And that completes the first of 8 lessons.